So a quick refresher, whenever I've got a vector which is acting at an angle to the horizontal. ठीक है जी, so here I've got a vector which is at an angle to the horizontal. Here is the horizontal surface and here happens to be the vertical surface. Fine. So this particular vector, it's making an angle theta with the horizontal theta. So let's call this vector V. This vector, it would have a vertical component which I'll call Vy, and it will have a horizontal component which I'll call Vx, right? Acha. So knowing the right angle triangle rules, I can say the first equation I can write over here is that V squared is equal to Vx squared plus Vy squared, right? The hypotenuse squared is equal to opposite squared plus adjacent squared. Yes, and this is the one that would be used to solve part A. But since we are talking about a refresher right now, if somebody asks me to calculate Vx, then for Vx, I can say it is equal to V cos theta. Why? Because if I write the formula for cos theta over here, cos theta is equal to adjacent by hypotenuse. So adjacent is Vx by V. So if I rearrange this thing, V by Vx and Vx by V, yes, adjacent by hypotenuse, Vx by V. So that rearranged, it gives me Vx is equal to V cos theta. Any confusion in this? No. The third thing I know for Vy, the formula is V sin theta. Why? Again, because if I look at the formula of sin theta, it will be equal to Vy by V. So if I rearrange this one, I get Vy is equal to V sin theta. So these are the three primary formulas that we use, and obviously they work when theta is with respect to the horizontal. If I were talking about an angle alpha which is with respect to the vertical, then theta, it would be a different story. If I would then this Vx and Vy, they would be switched. So with respect to alpha, Vx will be equal to V sin alpha and Vy will be equal to V cos alpha, right? So that was a 2-minute crash course on all the vectors and how to find their components and stuff. So in this particular diagram, we are given what? We are given V itself, vector V. We are given the vertical component of it, and we are supposed to find the horizontal component. So the equation which uses the vector itself, the vertical component and the horizontal component, it happens to be the first one, this one. Did I confuse you or did you understand this thing? You didn't understand. ठीक है जी. अच्छा जी, for the first question, it says, let's go back to the way we used to solve questions full step. अच्छा जी, the first step is we have to find the requirement. What do I have to calculate? I have to show that Vx is 3.6 meters per second. So I have requirement is Vx is equal to what? And I have to prove that it is 3.6 meters per second. So in other terms, I have to find Vx. Agreed? Acha ji, in order to find Vx, I'll have to see what information is already given. So I'm given value of V, which is 6 meters per second, and I'm given value of Vy, which is 4.8 meters per second, right? Now I'm looking for a formula which contains all these three values and just these three values. Which formula contains Vx, V, and Vy? 12.96 is Vx squared. In order to find Vx, I'll have to take square root of both sides. Hmm. As required or as asked to be proved. So the question says that we have to show that Vx is 3.6 meters per second, right? And we just showed that it is 3.6 meters per second. ठीक है जी. So this sort of thing, it gets asked for a very, I mean, it's something very basic. So it's just for 1 mark. See? Acha ji. Moving on to the next part, the ball. So it's about a ball. The ball leaves the ground at t is equal to 0, reaches maximum height at 4.9 seconds. Separate lines show the variation with time until the ball returns to the ground. Vertical, ठीक है जी. So we have to do this one now. Would it work? Hopefully it would. ठीक है. नहीं. Just a second. Just a second. ओहो, कैप्स लॉक की तस्वीर आ जाएगी. चलो खैर. ठीक है जी. Would you like to give it a try on your own before I show you the solution for this one? No? The voice is breaking. Is it my bad internet connection or yours? अच्छा. अच्छा ठीक है जी. अच्छा, let's see. ठीक है. ठीक है. The ball leaves the ground at t is equal to 0. So for the ball, I have seen that it has got an upward trajectory. So this point over here, t is equal to 0. At this particular point of time, the ball is leaving the ground over here. ठीक है. Then what happens? Sketch show the variation with time t until the ball returns to the ground. How does the vertical component of the velocity change, and how does the horizontal component of the velocity change? ठीक है जी. So we have to draw two lines, and for each line we'll have to show how do these components of the velocity they change. Let's do the horizontal component first, because if you remember, for the projectile, so if I've got a projectile like this, we discussed that it has a vertical component and it has a horizontal component. So this would be the vertical component, yellow one, and this green one, it would be the horizontal component. So for the projectile, the initially when I kick it upwards, it would have, as I mentioned, some. ठीक है जी. Its vertical component, it would keep on changing as it goes up, and so this is the path that would be followed by the projectile, right? So its vertical component, as it goes up, would it increase or decrease? As the ball goes, so this is point O from where the journey starts, and it reaches point A. The question is the vertical velocity of the ball, the vertical component of the velocity. Along the way, will it increase or decrease as it goes from O to A? It will decrease. Why will it decrease? Because at all times there is g which is downwards. There is downward acceleration due to gravity. So if I gave the ball an initial acceleration upward, I gave the ball an upward kick, I gave it some upward velocity. Throughout the motion of the ball, the downward acceleration will keep on accelerating it downward. Hence, its upward velocity will keep on reducing. And that is why when it reaches at point A, it does not go up any further, because by the time it reaches point A, it has lost all its vertical velocity. And then G, it keeps pulling it down, 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 down. And here it keeps on increasing until when it hits the ground, it hits with maximum velocity, with maximum vertical velocity. Okay, you did. Sure. So for a projectile, while the body is moving upwards, the vertical component of the velocity keeps diminishing until the body reaches maximum height. Diminishing, reducing, diminishing. Vertical component of the velocity keeps diminishing as the until the body until the body reaches max height. ठीक है? At max height, vertical component of velocity becomes zero. ठीक है जी. अच्छा, and now at point O and at point L, let me call this point over here L, Vy will be the same. So if over here it was 4.8 Vy, at this point it was 4.8, at maximum height Vy will be 0, and when it comes down it will again be 4.8. Okay, and as this goes from O to A, it will be deceleration. So at this point it would be something else, at this point it would be something else, at this point it would be something else, but there would be a constant deceleration. There would be a constant deceleration. Why constant deceleration is important in this case? Because we have velocity time graph and the gradient of velocity time graph that gives acceleration. So if the body is undergoing constant deceleration, the gradient will be constant. Hence, we'll have a straight line. Too much to wrap your head around? Okay, one by one. You understand it? ठीक है, ठीक है. अच्छा, so the vertical component of the velocity, first of all, we are told that the ball reaches the maximum height at 0.49 seconds. So let's first identify 0.49 seconds, 0.4, 42, 44, 46, 48. So somewhere over here I have 0.49 seconds. This yellow dot that I've put. Yellow isn't visible. Let me make it. Astaghfirullah. Let me make it red. ठीक है, this red dot over here just behind 0.5, this is when the ball it reaches the maximum height, this point of time, right? Initially when I kicked the ball, I was shown that this ball it had a vertical velocity of 4.8 and at 0.49 second, so at 0 second the ball had a vertical velocity of 4.8, so that would mean this point up here, this point, right, just below 5 velocity at time 0. Do you agree? My question is coming from that up point to down this point, would the velocity be a straight line or would it be a curve? So should I draw a line like this, or should I draw a curve like this? जी madam. जी जी, it will be a straight line. Very good, very good. ठीक है जी. अच्छा, तो at 0 it becomes, at 4.9 second the vertical velocity it becomes 0, and look, it took the ball 4.9 seconds to lose 4 point, sorry, it took 0.49 seconds to lose 4.8 meters per second, right? And then it will again take 0.4, the as much time as it took to reach the maximum height, it will take the same amount of time to reach the ground, and it will hit the ground with same velocity. It took 0.49 seconds to reach maximum height from ground. It will take 0.49 seconds to come back to ground. One thing. And second thing, it left the ground with 4.8. It will come back to ground with at 4.8 meters per second speed. Okay. So the next time that I have to note is 0.49 plus 0.49 plus 0.49. It will be 0.98. So I'm looking over here. 0.98, 0.98. This is 0.98, but at time 0.98, the velocity will again be 4.8 as we discussed. So 4.8 is over here. But why am I marking in the negative trajectory? Because now initially the velocity was upwards, now it will be downwards. Yes. So the downwards is shown by, if upwards was positive velocity, the downward will be the negative velocity, right? So this complete graph from there to this point, now it will be extended like this. You can't see what I'm drawing? Aren't there any red and blue lines on the graph? ठीक है, ठीक. चलें. So what I was saying is that now it will gain velocity in the opposite direction, and every passing second it will gain velocity, so negative values would keep on increasing, or the absolute value will keep on decreasing until it gets to 4.8 again in 0.98 seconds. Yes, so it will be like this. Any confusion on this? Acha ji, no confusions on this then. Acha ji. Acha ji, madam, one thing to add over here, that for this explanation, the first explanation, I've added the sentence, this is because of gravity. And now if we consider the the horizontal component of the velocity, I told you before, and the recap is that this horizontal component, it stays the same at all points. Vx over here Vx over here, Vx. This horizontal component, why does it stay same? Because we know that for the inertia, that a body, it would continue its state of motion or its state of rest until it is acted upon by an external force. Since there is no force opposing the motion of the body along the x-axis, there is no air resistance. Hence, the velocity once given, that velocity would maintain. So if there is no air resistance and I've got a ball over here and I kick it upwards, if I notice any change in its speed, it would be only because its vertical component, it keeps on changing. Vy keeps on changing. Vx, it stays the constant. It stays constant throughout the projectile. Okay. So Vx, we calculated that it was 3.6. So once it initially acquires 3.6 velocity, like shown over here. So it would be at time 0, the velocity is 3.6, and then onwards until the end of the motion of the body at 0.98 seconds, this would stay constant at 3.6 like this. ठीक है जी, simple. And if you want to note down this explanation as well, you can note that too. Noted? ठीक है जी. अच्छा, now let's look at the last part of the question which we are supposed to do right now. Part C, calculate the maximum height reached by the ball. ठीक है जी, let me copy this, or without copying it, let me just note it down over here. Maximum height reached by the ball. अच्छा जी, any idea, any clues of how we used to calculate the maximum height reached by the body? So max, acha, just hold on for a second. If you say maximum height is 0, it means the body never leaves the ground. You're close, you're just mixing one thing up. Maximum height can't be 0. So what we will say is that I just take so this is the body, this is the initial kick given, and here it reaches the maximum height, right? And along this projectile, we know that Vx isn't changing. So let's assume the vertical velocity only. Initial vertical velocity Uy is 4.8, right? And final vertical velocity Vy is 0, right? So I can write over here initial vertical velocity. So first of all, what do I have to calculate? I have to calculate time it takes to reach the maximum height. Part C, that is that what it asks? Maximum height, no, maximum height reached by the ball. Fine, maximum height. So I have to calculate S. I don't have to calculate T. I have to calculate S. ठीक है जी. अच्छा, what am I given? I am given the initial vertical velocity. Let me call it ux. This is 4.8 meters per second, right? Then I know final vertical velocity, which you correctly identified. At maximum height it will be 0. Final vertical velocity. Vertical velocity. This would be v. Sorry, this was not ux, it was uy, and it will be vy. So final vertical velocity is 0. Do I have any other piece of information? Yes. What is that? One thing I know, A will be equal to negative g because the body is going upwards. So A will be minus 9.8 meters per second squared. Also, I know the time it takes to reach the maximum height that was given in the previous part. So we were told that it reaches the maximum height in 0.49 seconds. So I'll have t as well, which is 0.49 seconds. Okay, so now that gives me a number of options. I can use the equation v squared is equal to u squared plus 2as. V squared is equal to u squared plus 2as, or I can use the equation s is equal to ut plus half at squared. We'll use both. We'll just to prove that we get the same answer from either of them. Acha ji, for this one, if I plug in the values in the first one, let's do with me. I'll have 0 squared is equal to 4.8 squared plus 2 into negative 9.81 into s, right? So 0 is equal to 4.8 squared is 23.04 minus 2 into 9.81 is 19.62. 19.62s. That gives me 19.62s is equal to 23.04, and s is equal to 23.04 by 19.62. 1.17 meters, right? We're calculating distance. Got it? Hmm. 42.6 is because you added these two. They cannot be added because 2.2 into minus 9.81, it's also multiplying with s. So it's 23.04 minus 19.62s. Move it to the other side, it becomes 19.62s is equal to 23.04. Initially, you shouldn't have added these two over here. Also, one would be positive, the other would be negative, so your answer can't be 43 point something or whatever. They'd get subtracted, even if you were trying to add them. Anyhow. Asha ji, I want to quickly do it with the next one as well, just to confirm that we are getting. I mean, you don't have to do it in exam, just to show you this thing over here. Hanji, then I'll have to leave for Isha. It's almost time. Acha, S is equal to U. What is U? 4.8. What is T? 0.49 plus 0.5 into minus 9.81 into 0.49 squared, right? From this one also I'm getting the same answer, 1.17 meters. This is just to show you whichever equation you use will get the same answer. Gee, are you getting the same answers now? You got it from the first method? Still on? Hmm. Okay, take. Are you sure? Any confusion at all? I can explain right now. ठीक है. अच्छा, so this is how we do. Just a quick reminder, when we are considering the horizontal distances, we will take the horizontal velocity and horizontal acceleration. Horizontal acceleration would be zero unless we are told that we are kicking something forward with some acceleration. This is for a projectile, remember. Okay, we are assuming that horizontally there is no force resisting the motion, so horizontal acceleration would be zero. Yes, that is why the horizontal velocity, it says the same throughout. Are you following me? ठीक है. And when we are considering the vertical distances, as in the maximum height reached, the time it takes to reach the maximum height, the total time for the complete journey, for which we'll have to calculate the time for the upward journey and then multiply it with 2 to get the time of downward journey as well. So for that, we will use the vertical component of the velocity only. That is the one that we'll be using. We won't be using the complete velocity. Things, hopefully, they are starting coming back to you. ठीक है जी. अच्छा, what I'll do is I'll take a break over here. I'm going to end the session right now. By the day end today, inshallah, I've got one more class after this. I'll try to send you a question. If I haven't, please send me a reminder message. Even though I'll try to remember and send it myself, but if I don't, please send me a reminder message. I'll expect you to please come to tomorrow's class having solved that particular question. I'll just send